Hello and welcome back to Azure Terraformer. Today, I wanted to talk about Azure resiliency. So first, we're going to start with a little bit of an anatomy lesson of Azure's global infrastructure. Then we're going to look at some resiliency strategies that are used on Azure, some compute options that go along with it, and then finally, how to layer on top of that with Kubernetes and optimize our workloads. So buckle up. We got a lot of stuff to talk about regarding how to build resilient systems on Azure. But before I get started, I just wanted to give a shout out to 2 new members of my channel who graciously support my channel by announcing to the world that they are official Azure Terraformers. So I wanted to give a huge shout out to Gregory Mirsky, who you can see on the Azure Terraformer Discord server, and even submitted a pull request to one of my open source Terraform modules. Thanks, Gregory. Really appreciate all the support. Next, we have Mohammed Nasirullah Sharif. Thank you so much for your support, Mohammed. Anyways, without further ado, let's get started. So we all know that Azure and those other cloud competitors out there have regions, right? But what does it really mean, right? And you can see from this map, there's a lot of them. Azure has, I think, over 60 at this point. You can count the dots yourself. I pulled this down off the internet, so it might be a little bit dated, but the point is there's a lot of them. And you can see here that there are many more that are even announced that are under construction. So the bottom line, the cloud is getting bigger, more regions are being rolled out. And what does that really even mean? Well, first of all, you need to understand what a region is. When we talk about one of those little dots on that map, we're actually talking about multiple data centers that are co-located relatively close to each other in a large geographic area. So when we talk about the region West US, for example, that's actually made up of multiple data centers that each have their own redundant access to the global network, redundant power supplies, backup, etc., physical security, you name it. Each one of these data centers probably has thousands and thousands of physical servers in it. And so the region within itself has its own redundancy. And when we talk about availability zones or AZs, that's really about taking each of these data centers and recognizing it as kind of its own distinct unit and its own fault zone, allowing us to distribute our workloads across it to improve the resiliency of our workload. Now, you might have heard of a multi-region deployment, and deploying across multiple regions can be a good idea. Here we have West US, we have East US. Of course, each of these regions actually represents multiple data centers, and the regions themselves are spread apart pretty widely, about 500 miles or so. Don't quote me on that. Now, the data centers within those regions are closer together, right? And as a result, the availability zones within a region have much lower latency. So when you distribute your application across regions, really it's about deploying 2 separate copies of your application, finding a way to replicate or not, depending on how your user populations are set up, and then load balancing traffic across those 2 different regions. There's some use cases that are absolutely perfect for this, and they include disaster recovery. Of course, you got big distance between regions, so if there's a regional impact affecting one region, probably is not going to be impacting the other region. If you have an application that has widely dispersed user populations, now this might be rather bespoke or it could be global. If you're a business or an enterprise, you might have large concentrations of your workforce in specific locations or geographies that are proximate to one of these regions. If you're building the next Amazon.com, you're targeting a consumer audience, and you're really talking about large geographical areas of consumers that are just all over. No idea where they are really. They could be anywhere. And then in those situations, you're really looking at what geographies across the globe that you need a presence in. Are you a North America only service? Do you want to service Europe? Do you want to service Asia? Do you want to service all the things? Do you want to service all the people everywhere? And that's when you really start getting into these hyperscale workloads that need to be everywhere across the planet. But do we always need multi-region resiliency? Not always. There are cases where you may not need that. And in those cases, multi-AZ resiliency might suit your needs. With multi-AZ resiliency, you're distributing your application across 2 or more of the availability zones within a particular region. Now, why might you opt for this type of resiliency over multi-regional? There's quite a few reasons. When you distribute across regions, you incur higher latency. So if you have a workload that is particularly sensitive to latency. Deploying it within region across availability zones can help you achieve both the fault tolerance that you're trying to achieve and high availability, but also the performance in terms of that reduced latency between your applications and services, especially as you scale. We talked about this a little bit earlier with businesses or enterprise. You might have regional user populations that are in specific locations, and it's okay if you have a concentration in a particular region. Deploying to secondary regions, while it might fit for a disaster recovery scenario, it becomes really unnecessary to support all your end users if they're all in one spot. And then lastly, especially for our friends across the pond, you might have data residency requirements where you don't want your data to leave a particular region. And so availability-based resiliency gives you a much better option. So we talked about regions, we talked about availability zones, we talked about different resiliency strategies. How do we actually deploy stuff to Azure in order to leverage these resiliency models? Well, at its most basic form, it starts with virtual machines. And so with loose virtual machines, we can provision them to any particular region that we want. But if we do that without specifying any sort of preference, Azure just assumes these virtual machines are strangers and not dependent upon each other. Now, traditionally, the way Azure solved this was by introducing an availability set. An availability set essentially wrapped these loose virtual machines into a logical container that identified their codependence to the Azure platform. So Azure platform knew, okay, these VMs are all kind of working together. I need to make sure that I deploy these in a relatively safe way. And then another mechanism that we have is called a virtual machine scale set, which accomplishes the same thing as an availability set, except it allows us to provision a dynamic set of virtual machines as our application scales. And because Azure already knows that this dynamically scalable set of virtual machines are all related to each other, working on the same task, it knows that it should distribute them in a safe way across the platform. So let's look at how that happens. We have a region, we have data centers in that region. Those data centers have racks with switches and lots of physical servers in them. All of these racks and servers are divided up into fault domains. These fault domains are basically boundaries identified where there are shared points of failure for all the physical servers within that segment. So it's really important that our virtual machines are distributed across those fault domains. So if one of those fault domains is impacted by a hardware failure, like a network switch going bad or a backhoe hitting the wrong wire, our virtual machines in the affected fault domain might be impacted, but our other virtual machines keep our application and service up and running. Now, when we do this with loose VMs, again, the Azure platform doesn't really know that these VMs are related to each other. So it's just going to, based on its available capacity, place those VMs wherever it has space. Now with availability sets and VM scale sets, again, that relationship is specified to the Azure platform, so it can intelligently place those virtual machines across those fault domains. Now there is one other topic that I thought I would mention, and that's a proximity placement group, which can be used in conjunction with VM scale sets and availability sets. And essentially, while it still maintains distribution across fault domains when associated with an availability set and a VM scale set, the proximity placement group tries to cluster those virtual machines closer together to really maximize performance. Now, this is a trade-off between performance and high availability. So there are some workloads where you want to opt for higher performance. Now, everything I've just covered is all about old way of achieving resiliency on the Azure platform using region-based virtual machines and fault domain-based resiliency. The availability set and the VM scale set are constructs designed to communicate that relationship between these virtual machines to the Azure platform so that it can intelligently and safely allocate those virtual machines to physical hosts that are distributed across these fault domains. Now, when we're talking about availability zones, how does this change? Now, availability zones, again, live within regions, and regions have multiple data centers with racks and switches and all the things. But the key difference is that availability zones recognize an even bigger order fault line within the region, and that's between the data centers themselves. So these data centers, they're separate buildings, they have separate access to power, they have separate power supplies, they have separate access to water and the global network through fiber connections. So it is possible that there could be a bigger issue affecting one of these data centers that affects one of these zones. Now, if you're distributed using fault domains, if you provision within an availability set or a VM scale set, it's going to locate you within one of these data centers. But if that data center has an outage, you're toast. So availability zones gives us much more distribution within the region across those data centers, which does incur a little bit more latency than fault domain-based resiliency, but not that much. And when you compare it to the additional levels of resiliency that you get, the trade-offs are often kind of a no-brainer. So now let's look at how we provision virtual machines in a resilient way across availability zones. Now, unlike the fault domain way, using loose VMs, we have the option of explicitly setting what availability zone we want our VM to be in. So if we're on a first-name relationship with our virtual machines, we know we got VM1, VM2, VM3. We can explicitly say, VM1, you're in AZ1, VM2, you're in AZ2, VM3, you're in AZ3. Done. We have that fine-grained control. Now, what happens when we are dynamically provisioning a whole bunch of VMs and we may not be on the first-name basis, right? It's, cattle instead of pets, right? Enter the VM scale set again, right? With the VM scale set, we've got 1 to n potential virtual machines. Now, in this situation, we simply have to set the zones that we want to make available to the virtual machine scale set. Now, most regions have 3 zones, but as you can see, we can select 1, 2, or 3 of the zones that we want this VM scale set to be able to provision to. So now if we do that and we provision with a VM scale set and we tell it, hey, Mr. VM scale set, I want to provision a bunch of nodes and you can provision them into zones 1, 2, or 3. Have a good time. That doesn't necessarily mean that the VM scale set is going to balance our virtual machines evenly across the availability zones. That just means it's going to put us at least in 2 availability zones. This is called zone redundant. So we tell the VM scale set there's 3 zones available. Take your pick. Based on capacity, the VM scale set will try and put us in 3, but it's a best effort. And so sometimes you can have kind of an asymmetric distribution across the availability zones, but you will get at least 2. Now, this can be potentially problematic if there's an outage, for example, in data center 2 or AZ2. In this case, 2/3 of our workload have been allocated to that availability zone. If there's an outage, we're going to immediately drop down to 1/3 capacity. Now, the virtual machine scale set's going to try and ramp us up in the other 2 healthy availability zones. But in the meantime, while that's happening, our users might have degraded performance, might have significantly degraded performance. So what are our options? Well, we can specify a preference to the virtual machine scale set that we want our virtual machines balanced across the zones. So this is a setting on the virtual machine scale set to explicitly tell the virtual machine scale set, I want you to be in all 3 availability zones. Balance my virtual machines across all 3 availability zones. That way I don't have a hot pocket in a particular zone, which makes me particularly vulnerable to a zone outage. And so zone balancing your virtual machines is actually probably the best way to achieve zonal resiliency. So it's important to recognize the difference between zone redundancy, i.e. I'm in at least 2 or more zones, and zonal resiliency, which is being evenly distributed across the zones. That way, if there is a zone outage, the impact is minimal. So now that we've established zonal resiliency at the foundation of our platform using compute, let's see what happens when we layer something like Kubernetes on top of it. Now with Kubernetes, as we know, Kubernetes has kind of a physical layer, which is the virtual machines underneath it. It's kind of funny calling virtual machines physical, but they're tangible things. They're not just records in an etcd database, right? And then Kubernetes has a logical layer, which is made up of Kubernetes constructs like services and pods that are ultimately scheduled to the actual physical infrastructure, in this case, virtual machines. Now, in an extremely simple service that we wanted to be zonally resilient, we might have 3 replicas, which will create 3 pods. And then we would want those 3 pods to be distributed across the nodes within the cluster. Kubernetes also has this thing called a cluster autoscaler. And this works with the VM scale set, kind of a similar fashion of automatically scaling out the physical infrastructure, the virtual machines that our pods are deployed to. So let's say we roll out a whole bunch more pods, then the cluster autoscaler is going to automatically scale out the number of nodes that we have in order to support the larger workload that we have on the cluster. This is called scale out. There's another scenario that I want to draw your attention to that the cluster autoscaler handles when one of the nodes fails. Now this could be, a transient issue with that particular node, or it could be a zone outage, right? So if we have VM1, VM2, VM3 spread across AZ1, AZ2, AZ3, let's say AZ3 goes down, virtual machine 3 is going to go down as well. And the cluster autoscaler will step in and set up a new VM in a healthy availability zone. So the cluster autoscaler, in addition to helping us handle scale out scenarios, it also helps us handle outage recovery scenarios. So what does this look like on our servers? Well, again, we have a region with our data centers 1, 2, and 3 and availability zones 1, 2, and 3. And we've taken care to make sure that our VM scale set has its nodes. And we've taken care to make sure that the VM scale set behind our AKS node pool is balanced evenly across the availability zones. And we have a Kubernetes service with 3 pods that we want to distribute evenly across these 3 nodes. But just like with the virtual machine scale set, unless we tell Kubernetes explicitly that our preference is that these pods are distributed evenly across these nodes, Kubernetes scheduler is going to distribute the pods in a best effort manner. And it might make a decision to schedule our pods in this way. And in this situation, even though our VM scale set is evenly distributed across the availability zones, in reality, our workload running on AKS has its pods over-provisioned within availability zone 2. And so just like when the virtual machine scale set was not evenly distributed across the availability zones, and we were much more vulnerable to an AZ outage, the same is true here. If there's an availability zone outage in AZ2, we lose 2/3 of our capacity because those 2 pods are living on a node that's going to die. So how do we explicitly tell Kubernetes to distribute the pods evenly across these nodes? And that's done with a Kubernetes construct called the topology spread constraint. Now this is an annotation of your service that allows you to communicate this preference to Kubernetes so that when it goes to schedule your service and the pods within that service, it knows that you actually want those pods evenly distributed across all these nodes. So in a topology spread constraint, the first thing and probably most important thing is the topology key. Now, Kubernetes has a whole bunch of different attributes that you can use here, but the one that you really want to pay attention to for AZ resiliency is the kubernetes.io/zone. Now, AKS is automatically setting this attribute for you. If you're going to roll your own Kubernetes cluster, you probably need to set this attribute by some other means. But essentially, if we configure our Kubernetes infrastructure using AKS to provision evenly across availability zones, then those nodes in those availability zones are going to report back to Kubernetes and tell Kubernetes what zone it's in, which is going to allow us to key off of that, no pun intended, in our topology spread constraint. Now, another attribute that's important to set is the max skew. And skew is basically like divergence from normal, right? So if we have 3 pods and we have 3 nodes and those nodes are evenly distributed across availability zones, and we want to spread our pods evenly across availability zones, then those 3 pods are going to be spread across those 3 nodes. And each node is going to have 1 instance of the pod. Now, max skew basically says, what's the maximum divergence from normal? So when normal is 1 pod per node, the max skew would be 2. Now this allows us to scale up. So if we want to scale up from 3 pods to 4 pods, where does the 4th pod go? Well, in this situation, the 4th pod can be allocated to any one of the nodes. Let's say it gets allocated to VM1. So VM1 now has 2 instances of the pod, and the other 2 nodes have 1 instance of the pod. So the skew for VM1 is 1. There's 1 extra pod on VM1. Now, if we continue to scale up, the 5th pod is going to go to VM2. Again, max skew is 1. 6 pods. We're back to even again because the 6th pod is going to go on VM3. The 7th pod, again, is going to go back on any one of the other nodes. And the max skew is going to stay level at 1. Now, what happens when we have a zone outage? In that case, let's say zone 3 goes down. Is it possible for Kubernetes to schedule all of the pods evenly across all zones? Not when all of the nodes within that zone are have instantaneously become unhealthy. So this situation is called unsatisfiable. So when Kubernetes detects that your topology spread constraint is unsatisfiable, what should it do? And in this case, we say schedule anyway. So basically, in what we're saying here is, okay, if there is a zone outage, just schedule it to a healthy node. It's okay. But once it is back to being satisfiable, i.e. the zone has been recovered and those nodes are healthy again, then go back to distributing evenly across the zones. So this setting is really important to help you in that outage recovery scenario so that your pods can get scheduled onto healthy nodes and then go back to being evenly distributed. So using a combination of the VM scale sets, VM balancing across zones, and the topology spread constraints in Kubernetes, we can get our pods evenly distributed across those nodes across zones, thus making us that much more zonally resilient. Anyways, I hope you found this useful. We took a little bit of a deep dive into the two different ways of achieving resiliency on Azure: a regional route using fault domains and an availability zone route using, well, availability zones. And we even looked at how we layer on top of that using something like Kubernetes to make sure that our Kubernetes workload deployments are optimized for the fault tolerance modes that are built within the Azure platform. If you're enjoying this content, please smash that like button and consider subscribing to the channel. It really helps out a lot. Also, if you want to help me keep doing what I'm doing and announce to the world yourself as an official Azure Terraformer, I encourage you to join Gregory and Mohammed in becoming channel members. It's a great way to help out the channel and me. Anyways, that's it from me. This is the Azure Terraformer, signing off.